Today we're going to be going over 2.3 guided notes covering solving multi-step equations. Yesterday we learned how to solve one-step equations, so today we're just going to be adding on to that and solving equations with more than one step. So before we jump into the steps and some examples, we're going to play a little game called Math Magic. So first I'm going to have you pick a number between 1 and 25. So pick a number, make sure you have that in your head. All right, you might want to have a calculator handy or a piece of paper to follow along with these directions, but now I want you to add 9 to your number. Now multiply by 3, subtract 6, divide by 3, and finally, subtract your original number, the original number that you picked. So, was your number 7? If I didn't happen to guess your number, you may want to go back and check your steps, make sure you followed them through. But now it's your turn. I'm going to pick a number between 1 and 25. Now, I'm going to tell you the steps that I'm going to do, okay? So I multiplied my number by 4, then I divided my number by 2, I added 6, then I subtracted 9, and my final answer was 27. Can you guess what my number was? All right, so let's write a mathematical equation to see if you're right. Let's check and see if we can figure out what my number was. So let's go back to the directions over here. It says I'm going to pick a number between 1 and 25. I just told you I'm picking a number. Right now you have a guess of what that number is, but we don't know for sure. So in mathematics, the way that we represent a number that we're not sure what it is with a variable. So since I'm Mrs. Montgomery, my number will be M. So we'll call it M is my unknown number that I started with. Then we'll just walk through and briefly talk about how to annotate each of these steps. So if I multiplied by 4, that means I'm going to multiply by 4. Divide by 2 means I'm going to divide by 2. Add 6 means plus 6. Subtract 9 means minus 9. And then my final answer was 27, meaning when I did all these things, it was equal to 27, okay? So let's try and put all of these steps together into one mathematical equation. So I want to start from the beginning. I started with an unknown number, M. The first thing I did to that number was that I multiplied it by 4. So I have M times 4. But actually, because this is variable and multiplication is commutative, you can do M times 4 or 4 times M. We usually would write this as 4M. So I've got 4M, I multiplied my number by 4. Then what did I do? Then I divided by 2. What did I divide by 2? Did I divide M by 2 or did I divide 4M by 2? Well, I divided everything up until that point by 2. So I'm going to do all of this, all of this divide by 2. Next, I added 6. What did I add 6 to? I added 6 to this entire piece right here. I multiplied by 4 first, then I took that answer and divided it by 2, then I took that answer and I added 6. And then finally, I subtracted 9. So I took all of these things and I subtracted 9. I don't need to use parentheses because if we think about order of operations, once I do this whole first chunk in parentheses, I'm going to work from left to right doing addition and subtraction. Finally, we need this last bit of information. My final answer was 27. That means that when I did all of these things to my number M, it was equal to 27. So actually, I see some things here that can simplify to make an even nicer looking equation. So I'll walk through those really quickly. First of all, when I look within the parentheses, I have 4M divided by 2. I can actually simplify this 4 over 2 and rewrite that part of the equation. So 4 divided by 2 is 2. And so if I'm multiplying my number by 4 and then dividing by 2, it's really the same thing as just multiplying my number by 2. So 2m. I can get rid of the multiply by 4, divide by 2, and I can make this a little bit more simplified and just say multiply your starting number by 2. Then what I'm doing is I'm adding 6 to the number, and then I'm also subtracting 9. We'll go back. This is the idea of like terms here. So these are like terms, they're both plain numbers, so I can actually combine those. And instead of adding 6, then subtracting 9, I'm basically doing some work and then undoing it. What gain or loss do I have when I add 6 and subtract 9? Well, I have a net loss of 3. And then all of this is equal to 27. So I was able to take all of that crazy work and turn it into an actually really nice and simplified equation that we can solve. So you might have used, a number of strategies in order to try and figure out what my original number was, but we're going to use a nice mathematical strategy, the idea that we started learning about last week of inverse operations, that subtraction and addition are opposites and multiplication and division are opposites, and we're going to use that to undo this and try to find my original number. So let's take a look at the steps for solving here. And you might have actually used these steps when you originally tried to find out what my number was, but we're just going to put a name to them. So just like these steps are actually almost exactly the same from last week. We're going to first locate the variable, and I want us to circle it. We're going to circle our unknown. Locate, remember, just means to find it. Then we're going to isolate the variable by using inverse operations. Inverse operations are addition undoes subtraction, and multiplication undoes division. So remember, isolate means we're going to try and get it alone. And then finally, we can still use our checking process by substituting the number we get into the original and seeing if it works out correctly. So let's try this on my little math magic equation here. And notice there's a couple notes over here. We're going to use inverse operations to work backwards because these steps that we just went over, they don't necessarily tell us what order to work in. Am I going to divide by 2 first, or am I going to add 3? Well, as you probably figured out, we want to undo exactly what we did in the first place. So the first thing I did, or the last thing I did, was add and subtract. So to get back to that number that I started with, I'm going to first undo this subtraction. So this actually is a rule that when we're using PEMDAS, when we're solving an equation, we're going to use inverse operations to work our way backwards. We're going to actually start with addition and subtraction. We're going to get rid of those first, and then we're going to get rid of any multiplication and division, and so on. And so that's this note down here. We're going to undo addition and subtraction first, and then we're going to undo multiplication and division. So let's work that out right now. So I've got 2m minus 3 equals 27. I'm going to start from the end, addition and subtraction. I want to get rid of this minus 3, and basically I'm working from the outside in, closer and closer to my unknown. So to undo a minus 3, I'm going to add 3 to both sides. Now, if I am writing plus 3 on the left and plus 3 on the right, I expect to see the exact same work on your paper. So minus 3 plus 3, this gives me 0, and actually this equals 0. I'm going to put a 0 on it to show then we have 2m plus 0, okay, which really means we just have 2m. And then 27 plus 3 is equal to 30. Then I have another step here. The m is still not totally alone. I'm not done. So in order to undo 2 times m, I'm going to divide both sides by 2. So when I divide both sides by 2, these 2's cancel, giving me a 1m, which is the same as m, equals 30 divided by 2 is 15. Is that what you guessed? Let's plug it back in and see if it's correct. So if I happen to start with the number 15, if I started with 15, and then I multiplied that number by 4, four times 15 would have given me 60, and then I divide that by 2, which is 30, and then I add 6, which is 36, and then I subtract 9, which is 27. So yes, 15 was my magic number. Good job if you guessed that in the first place. And if you didn't, hopefully you can kind of see how we're able to think through that. So now we're going to take a look at several more examples. First, I have 5x plus 3 equals 23. So first step is always locate the variable, circle it or highlight it. I've got an x here that I'm trying to solve for. Then we're going to get that x by itself by using inverse operations. Remember, I'm going to undo addition and subtraction first, then multiplication and division. I'm going to work from the outside in. So I'm going to first get rid of this plus 3. So in order to get rid of a plus 3, I'm going to minus 3 here and here. I expect to see the same thing on your paper. 3 minus 3 is 0. 23 minus 3 is 20. And all I have left over here is 5x, or 5 times x. The x is still not completely alone, so I need to get it by itself. The opposite of 5 times x is that I need to divide by 5. 5 divided by 5 will give me a 1x, which is the same as x. And if I divide by 5 on this side, 20 divided by 5 is 4. So my x value here is 4. You could do a quick mental check. If I plug in x equals 4, 5 times 4 is 20, 20 plus 3 is 23. That actually is correct. You can always check yourself. So next I have 7/8 p minus 4 equals 10. My variable here is p. Now I want to get rid of that minus 4 first so that I can get in closer to the p. So to undo a minus 4 to get to 0, I'm going to add 4. And if I do that there, I must also do it here and show my work. Negative 4 plus 4 gives me 0. 7/8 p plus 0 is the same thing as 7/8 p. And then on this side, I have 10 plus 4, which is 14. Now, we learned about this last week. Right here, I'm multiplying 7/8 times p, but I'm multiplying by a fraction. So what we do to undo that, or get rid of it, is we multiply by its reciprocal, its flip-flop. So if I multiply by 8 over 7, the 8's will cancel, and the 7's will cancel, giving me 1p, or just p. If I multiplied by 8 over 7 on the left, I have to do the same thing on the right, 8 over 7. The way that we multiply, you can plug this straight into a calculator to help you, but I'm going to do 14 times 8, and then divide that by 7, and we get p equals 16. Moving on, I have 16 equals d minus 12 divided by 14. My variable here is d. All right, so this one is a little different. What we've been doing so far is undoing addition and subtraction first, then multiplication and division. However, this one's a little weird because remember, I've talked about this over the past couple weeks. When we have a fraction like this, you kind of treat the top and the bottom as totally separate things. And if we want to use this idea of working from the outside in, kind of zooming in on our variable, we actually need to just kill the denominator first. We need to get rid of the denominator. So what we're actually going to be doing is undoing this division first. So this is only the case when we have our variable is in the numerator, or if it's in the denominator, we need to try and get that by itself first. So in order to get rid of this is d, because there's kind of like parentheses going on here that we can't see. This is a chunk on top. And so we want to get that chunk by itself. So this is d minus 12, and it's all being divided by 14. So to undo a divide by 14, we're going to multiply by 14. So 14 divided by 14 will give me a 1 on the bottom, which is the same as setting the denominator by itself. If I multiply by 14 on the left, I have to, on the right, I'm going to also do it on the left. 14 times 16 is 224. Now, in order to get rid of this minus 12, I'm going to add 12. Minus 12 plus 12 is 0, so I have d plus 0, which is just d. And if I added 12 there, I need to also add 12 here. So 224 plus 12 is 236. All right, finally I have g divided by -5 plus 3 equals -13. So yes, we do have division here, but this is different than the example we just saw because the g is like by itself on top. So if we're working from the outside in, we're going to go back to starting with getting rid of this plus 3 because that's going to get us closer to our variable g. So to get rid of a plus 3, we're going to subtract 3, which equals 0. I'm going to subtract 3 on this side as well. I'm left with g divided by -5 equals, now be careful here, this isn't 13 minus 3, it's -13 minus 3, so I'm getting an even more negative number. So I'm getting -16. This is g divided by a -5. I want to get rid of the negative and the 5, so I'm going to multiply by a -5. These will cancel, leaving me with just g. If I multiply by a -5 over here, a negative times a negative is going to make a positive. 16 times 5 is 80. All right. One more point I'd like to address today. We can also use the same process to solve for a certain variable in a mathematical or a scientific formula. So you might have actually done this before in like middle school math when using formulas for area, volume, perimeter, or maybe even in science class this year, you've rewritten formulas. So it might be a little confusing because we're going to have more than one variable, but it's going to tell you which variable to solve for. And actually, the examples that I pulled for the guided notes, these are probably formulas you've seen before. So first I have P equals 2 times the length, 2L plus 2W. This is a perimeter of a rectangle, so you've probably worked with this before. So P is perimeter equals 2 times the length plus 2 times the width. Now, you would use this if you knew the perimeter and you knew the length and you were trying to figure out the width. We would want to rearrange this formula to solve for W. So all that means is we're trying to get the W by itself. So we're going to do the same exact things we've been doing. We're just going to be moving things around. We're not necessarily going to solve for an answer, but we're going to solve for W, meaning we're going to get it by itself. So the W is over here. We're going to use our idea of backwards PEMDAS. We're going to get rid of anything through addition and subtraction first. So in order to get this 2W by itself, I need to get rid of this 2L, okay? So what I'm going to do is I'm just going to move it to the other side. If I have 2L minus 2L, that's going to equal 0. And so I'll be left with 2W. But if I subtracted 2L there, I need to also subtract 2L over here. Now, we don't know what P is and we don't know what L is, so I can't actually get a number here, but I'm just going to write it as I see it. Perimeter minus 2L equals 2W. The W is still not completely alone. I'm multiplying it by 2. So to get rid of that 2, I'm going to divide by 2, which gives me 1W, or just plain W. And if I divided by 2 on this side, I need to divide by 2 on this side. But the thing is, I need to divide everything by 2. So W is equal to P minus 2L divided by 2. And this is it. This is where we stop. We're not going to get a single number. But then, if you knew perimeter and you knew length, you could plug those right in here. You could plug in the perimeter, plug in the length, and you could solve for the width. So like I said, you maybe have done this before. but we're just going to show that you can do it here too. This next one, we have A equals LW. We're solving for L. This is the area of a rectangle. So area equals length times width. Well, if we knew the area and we knew the width, but we were trying to find the length, we would want to try and get that by itself. So all I'm doing here is length times width. So to get rid of the width over here and get length by itself, I'm just going to divide by the width. Width divided by width cancels, leaving me just with length. If I divided by W on that side, I'm also going to divide on this side. So L equals area divided by width. And that's it. Finally, I have D equals RT, solve for R. This is distance equals rate times time. Maybe you've used this in math, maybe you've actually looked at this in science. So if I know the distance and I know the rate, if I know the distance and I know how long it took, the time, then I can solve for the rate. So I need to get that R by itself. So once again, I just have rate times time. To undo times, I'm going to divide by T. I don't want the T over here, so these will cancel. So I'm left with R equals, if I divide by T there, I'm going to divide by T here. Well, R is equal to the distance divided by the time. So that's how I can easily solve for the rate. All right, so a challenge for this week, if you're up for it, would be to use the same process that we used in the start of this lesson to try and come up with an equation that allows you to figure out how I knew your answer was 7.